So in this question, we're asked to prove that cos 3 theta over sine theta plus sine 3 theta over cos theta is equivalent to 2 cot 2 theta. So to begin, the first step we're going to make is we're going to multiply out our fraction, and we're going to get it into one big fraction with the denominator sine theta cos theta. So our first move here will be to multiply cos 3 theta by cos theta. And what we're going to do is we're going to work with this left hand side and work towards this right hand side. So therefore we have cos 3 theta multiplied by cos theta. Then we'll have sine 3 theta multiplied by sine theta. So that'll be plus sine 3 theta multiplied by sine theta. And then, as we know from multiplying fractions, we'll then have sine theta multiplied by cos theta as the denominator of this single fraction here. So then now we have a term with cos 3 theta and cos theta and sine 3 theta and sine theta. So we need to have a think about trig identities, and do we know any trig identities which we can use to help us? So we know, taking a note down here, that if we have cos of a minus b, then that is going to be equal to cos a multiplied by cos of b, and then we're going to add sine a sine b. So this right hand side here, cos a cos b plus sine a sine b, this is what we have here on the numerator. So we have that a is going to be equal to 3 theta and b is going to be equal to theta. So we can write this numerator as follows, where we have cos of a minus b, so that will be cos of 3 theta minus theta, and then we divide this by our denominator. It doesn't change, so that remains sine theta cos theta. And then we can tidy up this here in the numerator, and that will be equal to cos of 3 theta minus theta, which is cos of 2 theta. And again, the denominator stays the same, and that's going to be sine theta multiplied by cos theta. So our next step is to have a look at this denominator and see if there's anything we can do or anything we know which will help us here. So we know we have the double angle formula, which is as follows. It is sine 2 theta is going to be equal to 2 sine theta cos of theta. So what we have here, 2 sine theta cos theta, is very similar to what we have here as our denominator. So to make this the same, we need to get rid of the 2. How do we do that? We can divide both sides by half. So therefore, our trig identity which we're going to use is going to be a half of sine 2 theta is going to be equal to sine theta cos theta. So what we can then do is we can replace sine theta cos theta with 1/2 of sine 2 theta. So therefore, this is going to be equal to cos 2 theta, and we then divide by 1/2 sine 2 theta. So then now we know that if we are dividing by 1/2, that is going to be equal to multiplying by 2. And then we know that when we have cos over sine, that is going to be equal to 1/tan. So in this case, our denominator here will become tan 2 theta. And we'll just note down here that cos theta over sine theta is equal to 1/tan theta. And then now we look back to what we're aiming for. We're aiming for 2 cot 2 theta, and we have 2 over tan 2 theta. Well, we can also use the trig identity that cos theta over sine theta is equal to 1 over tan theta, but we know that this is also going to be equal to cot of theta. So therefore, we can now use this last trig identity here, and we can conclude that this is going to be equal to 2 multiplied by cot 2 of theta. So therefore, write a concluding statement, we have shown that cos of 3 theta divided by sine theta plus sine 3 theta divided by cos theta is equivalent to 2 cot 2 theta. And this is what the question was asking for, so we'll write as required. And that's us completed the proof. So this question was worth 4 marks, and we received our first mark for multiplying out our fraction and getting it into one single fraction. We then received our second mark for using our first trig identity, so using the fact that cos of a minus b was equal to this term here, and then implementing that here. We then receive our third mark for knowing to use the double angle formula and getting to cos of 2 theta over a half of sine 2 theta, and then we receive our fourth and final mark for going from this stage here to this stage here, so knowing that cos theta over sine theta was equal to cot theta, and then we pick this final mark up for concluding with a correct statement at the end here. So in part B of this question, we're asked to solve for theta, where theta is between 90 and 180 degrees. And we're solving the equation which we were presented with in part A of the question, and we remember that it is cos 3 theta over sine theta plus sine 3 theta over cos theta, and we're making that equal to 4, and we want to solve for theta. So we remember what we proved in part A is that this expression here was equal to 2 cot 2 theta. So we know that we can then write this. So we'll have 2 cot 2 of theta is equal to 4. But then we know that 2 cot 2 theta is going to be the same as 2 over tan 2 theta. And then this is something that we can use our calculators and our knowledge of trig to solve. So therefore, we'll just note down here that this is then going to be equal to 2 divided by tan 2 theta. So then going back to what we have, we can write that 2 over tan 2 theta is going to be equal to 4. So we can then multiply both sides by tan 2 theta, which will give us 2 is equal to 4 tan 2 theta, and then we can divide both sides by 4. So this will give us tan 2 theta on its own. So we have tan 2 theta is equal to 2 over 4, and we know that that is equal to 1/2. And then this is something that we can use our knowledge of trig to solve. So we can then say that 2 theta is going to be equal to arctan, so tan minus 1 of a half. And this is something that we can put into our calculators. So we'll therefore have that 2 theta is going to be equal to 26.6 degrees, rounding to 3 significant figures. And then we'll use our cast diagram. So we draw that here. And we first tick the all box because we don't have a negative here. We have a positive, so we tick the all box. And then we're working with tan, so we tick the T box. So this means that we're going to have a second solution at 180 plus 26.6. So this means that 2 theta is also going to be equal to 206.6 degrees. So then we can now solve for theta by dividing everything by 2. So we'll have here with our first solution that theta is going to be equal to 13.3 degrees. And then we divide 206.6 by 2, which comes out as 103.3 degrees. And we remember in the question we were solving for theta between 90 and 180. So therefore we can say that 13.3 is not a valid solution because it's out of range. But we see that theta being equal to 103.3, that's a valid solution. So therefore we conclude that theta is going to be equal to 103.3 degrees. And we're asked in the question to give our solutions to one decimal place, and that's what we've done here with 103.3 degrees. So in this question, where were our marks available? So we achieved our first mark for getting to this stage here. So when we said that 2 over tan 2 theta was equal to 4. So basically, if we're using our knowledge of what we did in the previous part of the question, we can then pick up our first mark there. We then pick up our second mark for getting to the stage where we knew to do arctan. So where we had that 2 theta was going to be equal to tan to the power minus 1, and then putting a half in. And we then receive our third and final mark for coming to the correct conclusion of 103.3 degrees, noting that 13.3 is out of range. So we need to remember this statement here and then concluding with our value of theta, 103.3 degrees.